Hello, sixth graders. Today we're going to be working with variables in number patterns. And it's kind of the beginning stages of algebra, so watch closely. It's actually some pretty fun stuff, and it's really easy as well. First of all, it says following are three special cases represent a general pattern. 17 plus 0 equals 17. Negative 43 plus 0 equals negative 43. 7/8 plus 0 equals 7/8. So describe the general pattern in words. This is what we're looking for. The sum of any number and 0 is equal to original number. The sum of any number and 0, so pretty much whenever you add a number up to 0, it is equal to the original number. Like I told you, it's really easy today. Okay, let's move on. For each general pattern, give two special cases. So it says 2 times m equals 3 times m. So what would be another scenario? What if we were to put something in there for m? For example, what if we put in 2 times 24 plus 24 equals 3 times 24? Or what if we wrote this down? 2 times 10 plus 10 equals 3 times 10. I think you guys would all agree with that. Because this would be, for example, here we'd have 20 plus 10, which is 30. 3 times 10 is 30. So we're kind of seeing a pattern here while we're working with these. This next one's s plus 25 hundredths equals 25 hundredths plus s. Well, let's put in some numbers here. What if we did 100 for s plus 0.25 equals 0.25 times 100? Or another example would be 0.5 plus 0.25 equals 0.25 plus 0.5. It makes sense. The equal signs make sense. For each set of special cases, write a general pattern. So now we're taking 3 to the second power times 3 to the third power equals 3 to the fifth power. So what we're doing is there's a 2 here, there's a 3 here, there's a 5. 2, 3, 5. 2, 3, 5. So if we were to write this as a special case, we would have x to the second power times x to the third power equals x to the fifth power. The x repeats, but at the same time, the 3's repeat. The 5's repeat, the 13's repeat. This would be a special case for the general pattern. For each set of special cases, write a general pattern. Let's take this. Look at this one. It says 7 times 0.1 equals 7 times. 3 times 0.1 equals 3 times. 4 times 0.1 equals 4 times. So we have s times 1/10. That would equal s over 10. I apologize. My s kind of looks like a 5, but it isn't s. Let's take another one here. 2 to the 0 power equals 1. 146 to the 0 power equals 1. 1/2 over to the 0 power is 1. So I would say a letter m to the 0 power equals 1. Anything to the 0 power apparently equals 1. There you go. That's how you would read that. Now we're going to do some practice problems. Watch close here. What number goes in the tens spot? Well, 10 times 10 is 100, so 1 times 10 is 10. Easy. Keep going. How does 1 get to 25? 1 times 25 equals 25. So 4 times 25 equals 100. 25 over 100 would be 0.2. How does 5 get to 100? 5 times 20. 1 times 20 would give me 20 in this box. 20 over 100 equals 0.20. How do we get to 75? Well, we're going into 100, right? So we get 100 here. Times 4 times 25 is 100. 3 times 25 is 75. 75 hundredths is 70.75. 0.75. 5 times 20 is 100. 4 times 20 is 80. 80 over 100 is 80 hundredths. Last problem of the day. 10 goes into 10. 10 times 10. 7 times 10 is 70. 70 points. Hopefully this helped a little bit for the intro to algebra and working with variables. Keep in mind, try and look at those patterns that happen between those problems, and then you'll be able to figure out something that stays consistent throughout. We will spend some more time working on this in math. Good luck. We'll see you soon.